Alright, welcome back. This is 7.3a, Hyperbolas and Writing Equations. So in this one, it's going to be pretty similar to ellipses centered at the origin, but there are going to be some key differences. So to start here, hyperbolas, it says right at the top, opens left and right. So in this case, unlike ellipses, our a squared value will always lead, regardless of whether it's y or x or it being greater than. And a difference here is that it'll be minus instead of plus. So in that case, when it's centered at the origin, oops, and I left it there, so it's centered at 0, 0, and it opens left and right, it'll open like this away from the center when it's x squared. Now over here, when it's y squared over a and then minus, this one is also centered at the origin since there's no hk. This will open up and then down, kind of like so. We'll get into better detail soon when we have some values there. And then another difference here is that to find c squared, we do a squared plus b squared. This is because now the focal points are going to be outside here, and then on the top and the bottom outside. So this is your foci. So I kind of highlighted some similarities and differences from the ellipses, but one difference, one big one, is that now it'll be plus and minus here. So just think the opposite, because with ellipses, this was a plus and then this was a minus, so they flip. And similarities are just that they have similar form and finding vertices, focal points, and centers. So graphing a hyperbola, some similarities again. Graphing the center, how many it's going to move right to left, and then how many it's going to move up and down on the y-axis. Now getting into some differences, we're going to be drawing a box. This will help us in a second. You'll see how, using the points on the x and y axis. Dash the diagonals of the box, then find the equation of the asymptotes using point slope form. That'll be where our values here can't cross, and I think you went over some asymptotes earlier this year. Then we're going to sketch the hyperbola and solve for the foci. So when graphing here, in hyperbola it always leads with a squared, and then to find a, we take the square root just like we did with ellipses. So this will be 3. There's no hk value, so it's centered at 0, 0. The vertices are going to be under our x value, as we can see right here, since that leads. So it's going to open left and right. So we found a to be plus or minus 3 here. So we go minus 3 and plus 3. Then our b squared value will be 4, and to find b we take the square root and we get 2. So we can plot those on the graph as well as plus or minus 2 on the y-axis. This is now where the box is going to come in. From the values around, we're going to make a box, connect them, and then we're going to find our asymptotes. So first, this is point slope form, so we're going to find our slope. Slope is rise over run. So from the center, if we go up 2 and over 3, that's the slope to get to this diagonal here. And then we'll have another one down 2 and over 3. So that'll be our slope. Now plugging in, for y1 and x1, we can use our center, which will be 0, 0. So we get y minus 0 equals, I'm going to use this first slope of 2/3. and then x minus 0. So simplifying, we have y equals 2/3 x. Then also, since it's 0, 0, these values here and here are going to be the same. So just substituting the other value in for slope, we get y equals negative 2/3 x. So these will be our two asymptotes here. So from the center through the diagonals, we will have asymptotes that we cannot cross. We will approach as close as we can get, but not cross. This opens left and right because the x value leads. So from the vertices, we're going to approach the asymptotes, but not cross. And that's both on the left and the right. Now to find the foci points, this is where it was a little different. It was a squared plus c squared because they're going to be on the outside. So this value should be bigger than our vertices here of -3 and 3. So a squared is 9, b squared was 4. So we have 13 equals c squared. So we have c equals square root of 13, which I found to be approximately 3.6. So that's good. It's just slightly bigger there. So the focal points are on the x-axis now. So we're going to have a negative square root of 13, 0, and then square root of 13, 0, approximately 3.6. So that's right there and right there. So there's where some of the similarities and differences come in. I'm going to skip this one here and then go right down to this one because this will help us kind of get a bigger array to help us on our homework. So just like with ellipses, we want it set equal to 1, so we're going to have to divide both sides by 100. So this will reduce down to x squared over 4 minus y squared over 25 equals 1. It leads with x squared this time, again. So leads with x squared. It's always a squared first. So a will equal 2. Our center is 0, 0 because there's no h or k. Then our vertices on the x-axis will be plus or minus 2. So we have a minus 2, 0, and a positive 2, 0. So in this case, it'll be minus 2 and plus 2. And then it follows with b squared. So b equals 5. So then for our what would be covertices will be 0, negative 5, and 0, 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now we can draw our box. Then we can find our slope again. Since the center is 0, 0, these values will be 0, 0. I'm going to first find my slope. So up, 1, 2, 3, 4, 5. This is our rise over our run, 1, 2. And then we also go down 5 and over 2. So now since this is 0, or y minus 0 equals m times x minus 0, it'll just be y equals our slope, which was 5/2 x. And then also plugging in our other value of m, we have y equals negative 5/2 x. So now we can draw our asymptotes through the diagonals. This is where we cannot cross. And it opened left and right since our x value led. So from the vertice, we approach our asymptotes. Get real close here, but don't cross. Then to find the foci, we had a squared plus b squared equals c squared. we can plug those values in since we found those up here. So we have 4 plus 25 equals c squared. So 29 equals c squared. C equals square root of 29, which I did not approximate this one, but it should be greater than plus or minus 2. So let's see here. We want square root. How do we do this here? I want to go back. 29 square root. Can we do it that way? No. I want to plug that value in. I didn't do it in the past. Shoot. Let's look here real quick. Let's see if I can do this fast. Probably not. Delete, clear, clear, clear. We want the square root of 29. There, now it wasn't so hard. 5.4 approximately. So approximately 5.4, and that's plus or minus the square root of 29. 29, 0. So 5.4, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5.4. 2, 3, 4, 5. Good. 1, 2, 3, 4, 5. Oop, this one wasn't. That's supposed to be 5.4 out there. That was about here. All right. Next, we're going to be writing the equation of the hyperbola. And they still give us some information down here. We can graph it to help aid us to write the equation. So first, it says our center is at 0, 0. Then our vertices are at 0, -5. And I'm going to scale this to 2. So 2, 4, 5, 2, 4, 5. And then our focal points are at -13 and +13. And these are our y values, which makes sense because our vertices were also on the y. So 2, 4, 6, 8, 10, 12, 13. 2, 4, 6, 8, 10, 12, 13. Now, since these are our vertices, we know that a is equal to that. We can use either one. And then to solve for a squared, we just square it and see that that's 25. Our foci, we found this is our C, so we can do the same thing here. Solve for it. 13 squared was 169. Oh, and my pen died. That's unfortunate. So once we have our c squared, which was 169, we can use that equation like we have done with ellipses to find our b squared. Then from there, we can find the box, find the slope, use the point slope, see our asymptotes, and then we can draw it and then write our equation based off that. So we have c squared equals 169. So a squared plus b squared equals c squared. So our a squared was 25 plus b squared equals 169. We're solving for b squared. So subtract 25 from both sides. We get b squared equals 144. But we want to know where to plot those, so we're going to have to find our b values. So take the square root, and we get 12. And since our vertices were on the y-axis, these will be on the x-axis. So 2, 4, 6, 8, 10, 12 to the left. 2, 4, 6, 8, 10, 12 to the right. Now we're going to use the box. And then we can find our slope again. So our slope is going to be, these are 2, so 2, 4, 5 over, and then it was 12 to the right. So I got 5, 12. Let's see here. I lost my notes. Which one are we on? 4? And then negative 5, 12. Yeah, that's right. This is 0, 0 again, since our center was 0, 0. So we have y equals 5 twelfths x, and y equals negative 5 twelfths x. Our asymptotes go through the diagonals. And then it opens up and down since our vertices were on the y-axis. So from our vertice, we approach the asymptote, and then we do the same on the top. All right, one more here. So they give us the center again. They give us the vertices, where the vertices are negative 4. This one I'm going to draw to scale. So 1, 2, 3, 4. 1, 2, 3, 4. And either one we can use to find a squared again. So a equals 4. So a squared equals 16. Now they give us the asymptotes. So that's an indicator, because when we found the slope, we can use either one for m, which was rise over run. So when it's 3/4, it's up 3, 1, 2, 3, and over 4. So we already see half of the box here. And then we know this is our b value. And then also minus 3, 1, 2, 3, and then that's the other half of our box. So our b value will be plus or minus 3 there. So to solve for b squared, we get 9. Oh shoot, and we forgot to write the equation up here. So the equation led with our y values, so it was of the form y squared over a squared minus x squared over b squared equals 1. And then we plug in our a squared and b squared. So we get y squared over, where is our a squared of 25 minus x squared over 144 equals 1. That's why it's important to check your notes and then make sure you're doing the right steps. So now we can draw those asymptotes. This is where it can't cross. The vertices were on the x-axis, so it opens left and right. So it won't cross here or there. Same on this side. Then we want to solve for our foci. So of a squared plus b squared equals c squared. So plugging in our values, 16 plus 9 equals c squared. 25 equals c squared. We have another good one here. So this is c equals 5, which should be outside of our vertices, so it is there, plus or minus 5. Those are our focal points. And then we have enough information to write our equation. Since our vertices were the x values, x leads, and then it was of this form, x squared over a squared minus y squared over b squared equals 1. And then we plug in our values for a squared and b squared. So then we have x squared over a squared, which was 16, minus y squared over b squared, which was 9. Set it equal to 1. And there is our equation for this hyperbola. All right, thank you for watching. Make sure to take your time and thoroughly understand each step.